Hi class, we'll be talking about counting techniques, and I'm just going to look at some baby examples just to get things going here. In the next few lessons, the idea is to count the elements in events from a simple sample space in order to calculate certain probabilities very, very efficiently. We'll look at different helpful rules and techniques, including some intuitive baby examples in this lesson, and then in the next two lessons, we'll look at what are known as permutations and combinations. So let's start out with a very easy baby example. I'm going to talk about what's known as the addition rule. Here's what I mean. Suppose that you can make a certain choice A in n sub A ways, and you can make choice B in n sub B ways. If you're only allowed to make one of those choices, you have n sub A plus n sub B ways of doing so. That's why it's called the addition rule. You're adding them up. So for instance, let's suppose that we go to Starbucks and we're going to have either a muffin or a bagel. Suppose that there are two choices of muffins, blueberry or oatmeal, so that's n sub A equals 2, and there are four choices of bagels, sesame, plain, salt, and garlic, so n sub B equals 4. We're going to choose one of these items, a muffin or a bagel, but not both. Not both. So that means we have 2 plus 4 equals 6 choices in total. Addition rule, very easy. Now let's look at another baby example involving what we call the multiplication rule, a little bit different. So here, let's suppose that I'm traveling from city A to city B. I can do this in n sub AB equals 3 ways. I can go by walking, by car, or by bus. So regardless of how I go from A to B, I can then go from city B to C in n sub BC equals 4 ways. I can take a car, bus, train, or plane. So it's called the multiplication rule because I can go from A to B to C using n sub AB times n sub BC equals 12 in this case, different travel itineraries. So one of which I can go from A to B by walking, and then I can go from B to C by car. I can go from A to B by walking or B to C by bus. Anyway, there are 12 of these different combinations. That's why it's called the multiplication rule. As another baby example, let's suppose that I roll 2 dice. How many outcomes can I see? Well, if I care about order, like we did in the previous lesson, so that 3, 2 does not equal 2, 3, then I can see 6 times 6 equals 36 ordered outcomes. So I just multiplied again. 6 times 6 equals 36. We saw that in the last lesson. I can extend that example a little bit by tossing n dice, and then I'll get 6 to the n possible n-tuple outcomes. Let's suppose I flip 3 coins. So if I'm interested in the possible sequences of those coins, there are 2 times 2 times 2 equals 8 possible outcomes, and let me list them out. So I can see heads, 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 tails, lazy, 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 all the way down to tails, tails, tails. There's 8 of those guys. Simple sample space, each of them have probability 1 over 8. So I may ask, what's the probability that the third coin is a head? That's my event of interest. The third coin is a head. To answer that, I can just look at the list, and I see that that event consists of 4 elements of the sample space. Go ahead, look at those 8, and you'll see that 4 of them satisfy the criteria that the third coin is a head. Therefore, the probability is 4/8. As a slightly more complicated example, let's suppose that I select 2 cards from a standard deck without replacement, and suppose I care about the order. So what do I mean by a standard deck of cards? I know some people may not be gamblers, and I'll explain this in more detail later, but let me just say for now that there are 52 cards in a standard deck. They're divided into 13 ranks from each of 4 suits, and a suit is something like hearts and clubs and spades and diamonds. The ranks are the numbers, 1 through 13. The number 1 is usually referred to as an ace, and the numbers 11, 12, and 13 are referred to as jack, queen, king. So, for instance, if I care about order, then a queen of spades followed by a 7 of clubs is not equal to a 7 of clubs followed by a queen of spades. So after that long-winded discussion, how many ways can I select 2 cards from a deck without replacement where I care about order? Well, it's easy. I can select the first card 52 ways, and then regardless of what card I picked in the first pick, I can select the second card 51 ways. So that's a total of 2,652 ways to select two cards. Now, if I replace the cards, well, then I'd be able to select two cards carrying about order in 52 squared ways. So we have to be real careful with the English here. Without replacement's a little bit different than with replacement. We'll talk about that a lot more coming up. Let's do another example. Here I've got a box of 10 socks. I've got 2 red socks and 8 black socks. I'm going to pick 2 of these without replacement. In order to make this a simple sample space, let's suppose that I secretly label the red socks red sub 1, red sub 2, and I label the black socks B sub 1, B sub 2, all the way up to B sub 8. So every possible way that I can pick these socks has the same probability. Let's let A be the event that both socks that I pick are red. So because this is a simple sample space, the probability of A is just the number of ways to pick 2 reds divided by the number of ways to pick 2 socks in general from the sample space. So the number of ways to pick 2 reds is just 2 times 1. Pick the first red sock, then pick the second one. The number of ways to pick 2 socks overall, well, there's 10 socks on the first pick, and regardless of the number of ways I choose that first sock, there's 9 socks for the second pick. So the answer is going to be 2 times 1 over 10 times 9 equals 1 over 45. So that's the probability that both socks that I pick are red. I'll go through another way to calculate this type of probability later on using what's called conditional probability. Let B be the event that both socks are black. So the probability that I pick a black sock by the same exact reasoning is 8 times 7 over 10 times 9. That's equal to 28 over 45. Finally, let C be the event that I pick one sock of each color. Since the events A and B are disjoint, we have by the law of complements, the probability of picking one sock of each color is equal to 1 minus the probability of not picking one sock of each color, which equals 1 minus the probability that I pick 2 reds or 2 blacks, and by disjointness, 1 minus the probability of 2 reds minus the probability of 2 blacks equals algebra, 16 over 45. Really easy. So we're now done with a bunch of the easy examples. We'll now talk about permutations and combinations, which are a little bit more interesting in the next 2 lessons. So we'll see you in a little while. Those will be kind of fun. You'll enjoy those.